Welcome to Rocking Math and our series on volumes. Let's take a look at a real-world application on the volume of a cylinder. Now, this is a very unique problem because we will have to look at what type of information that is given us and determine how we should proceed. So let's construct a problem with our C-plan do reflect method. What's given is the fresh chili company is changing the size of their cans of chili. The new can needs to hold 500 cubic centimeters of chili. The height of the can is to be 11 centimeters, and we were asked what must the radius of the new can be, and to round our answer to the nearest tenth. Well, again, we're going to use volume, and we are using, so let's see, there we go. Now we will go to a thicker, more enlightening. Okay, so let's change this from black since we, okay, so what we have is we have the formula, and the formula is volume is equal to big B times height. Now in this case, we know that big B is going to equal to the actual area of a circle, and that's going to be pi times radius square. Okay. Now, what we want to do here is we want to go back to our formula, and we want to say volume is equal to pi radius square times the height. Now, if we go back and see what the problem is giving us, the problem says the can needs to hold 500 cubic centimeters. Guess what it's giving us? It's giving us what is the volume. So our volume is actually 500 centimeters cubed, and that's going to equal to, well, let's fill in while we're here. Pi, how much is pi? 3.14. So we know that 3.14 is pi. Radius square we don't know, but we also know that height is 11. Okay, so I'm going to even put here that height equals 11. So all of this information we know, we just don't know what radius square is. And as a matter of fact, we can even go further than that and say that our height is 11 centimeters. Okay, so from here we'll go and look at what we can do to solve for our radius. Well, again, we have 500 centimeters cubed is equal to, and let's go right ahead now and multiply 3.14 times 11. So if we do that, 3.14 times 11, that's going to give us 34.54 centimeters, and that's all time radius square. Okay, well, what we need to do now is get radius square by itself. Since it is being multiplied here by 34.54 centimeters, we need to divide 34.54 centimeters both sides. Remember, what we do in an equation to one side, we have to do it to the other side, or we unbalance the equation. So we go in here, and what we can do is when we divide these out, it becomes 1 centimeter. So actually the centimeters then divide out, and this becomes radius squared, because that all is equal to an imaginary 1. So we know that's an imaginary 1, but we really don't have to put that. We'll just leave it as radius squared. Now the question is, what do we get when we divide 34 into 54? And what I want to do is I want to show you piece by piece and show you exactly what we're doing. So what I'm going to do is I'm going to divide actually 500 into 34 first of all. So I'm taking my coefficients and I'm dividing 500 by 34.54, and I'm also dividing centimeters to the third by centimeters. Okay, so again, let's see what we'll get. So there's my r squared is equal to, so 500 divided by 34.54 will give me, looks like 14.48. We're rounding right here. So we have 14.48. Now, let me say this. When we are dividing variables into a variable, if we are going to multiply, we add. So if we're going to divide, we do the opposite of adding, which is subtract. So what we will have, follow me up here, we will have centimeters 30 minus 1, because that's centimeters to the first power. And when you subtract that, you would get centimeters squared. So what I have here is 14.48 centimeters squared. Okay, now as we go on, if you look on the right side, it's telling us that that answer is r squared. So we have to be able to find what is the square root of r. So in order to do that, we will put this, all of it, under the radicand, and we would have 14.48 centimeters squared is equal to r. And now we need to determine, well, what is it? So, you know, we have our own little unique way of doing it. Actually, I have my own little unique way of doing it, so we'll take a look at it. I'm looking at what in the world would we find a number 14.48. So if I see, I'm looking, well, it would probably be between perfect squares 9 and 16. So if that's the case, I need to determine, well, what are the numbers? So here they are 3 and 4. So if my method, if I subtract 9 from 14.48 and subtract 9, I will get roughly 5.48. Now, if I subtract 16, actually subtract 14.48 from 16, then I would get roughly 1.52. So my answer is really close to my 4. So I'm going to call it probably 3.7, and I would say that that is roughly 14.48. Now, do I know this? No, but it is a pretty good educated guess. Now I do have handy a TI Inspire, so what I'm going to do just to see where I am is I'm going to go in here and put in the square root of 14.48. I wish I could show this to you on screen, and I get actually 3.8. Okay, so that's a pretty good guess there. So we'll go ahead and use 3.8 since that's what TI said that it would come to. So here we would have, now another thing, what is the square root if we take the square root of these centimeters square? Well, of course, it's easy. It's up here. We know that centimeter times centimeter gives us centimeter square. So this becomes centimeter. So now I'm looking at 3.80 is approximately, and then we're talking about, and let me make sure I put this in because I said I really want to let this follow with you guys. So approximately 3.8 centimeters is approximately the radius. So I think that's a very good estimate. So what we actually did was, and it said round to the nearest tenth, which would be, if we round, 3.8 is approximately the radius. So what we've done is we went in this problem. It was a backwards working problem. It gave us the volume, and then we were solving for a literal equation, or just actually solving for, in this case, h. Oh, I'm sorry, we were solving for the radius. So please go back and look at this over and over and over again until you really feel comfortable with working these type of problems, especially the backwards working part. Again, thank you for joining us on our series on volume.